Okay, so VMS.
Yes. Have you ever used it?
What? Sorry?
Have you ever used it?
I have actually. I was teaching in the United States, and the college had a VMS installation, and one term we used it, and then we moved over to digital equipment Rainbow personal computers, which and this was in the early 80s, or 1983, 84, 85 sort of time.
That was back when DEC was probably the second largest computer company after IBM.
Yeah, that's right.
Because Sun, Silicon Graphics, and so on came later, 90s essentially. And they've essentially disappeared again. Silicon Graphics doesn't exist anymore. But for a time, that's what people were using as, workstations and so on. They had Silicon Graphics or Sun workstation, or maybe something from HP, something like that.
Well, I've recently rebuilt my computer. I happened to discover the box that the old motherboard came in, and it proudly said on it, 2011 technology.
So this is your Linux PC or Windows?
Yeah, my Linux PC. So it's now got 2022 technology, and the hardware I've got is absolutely extraordinary compared to what was available to somebody like myself 10 or 20 years ago, let alone 30 years ago. And software has a sort of persistence of its own, but the hardware seems to grow at an extraordinary rate. And
go ahead.
I bought a NVMe solid state disk, and it's about this big. It's about the size of your finger, and it contains a terabyte.
And it costs what, 100 quid?
It costs £100, and it's 4 or 5 times quicker than a solid state disk.
Yeah, and that's 10p a gigabyte.
Sorry?
It's 10p a gigabyte.
10p, that's right.
And I remember when I was in the Netherlands, I bought a 4 gigabyte hard disk and paid like 500 guilders for it.
Yeah.
And someone once remarked that software is much more inertial than hardware, although you might initially think that hardware has more inertia because it's hard, and software is just something ephemeral, if you like. But actually, software is actually has much more inertia to it. I mean, we're still running Dan Knuth's code, right?
We still use Roman numerals.
Yeah. And, to some extent, I mean, some things I used to do, with a batch job running overnight, can now do interactively because the speed has increased so much. And so that's what's interesting about VSI putting VMS to x86 is because, the modern hardware is so much faster than Itanium, or even, which is really not being developed anymore. So as long as Moore's law still holds, then anything, a few years old is hopelessly out of date. But of course, it depends on what you do. If I'm editing a text file, the VAX is fine. I don't need more processing power. Yeah, but if you're running LaTeX on a document which is a few hundred pages, then it does make troubleshooting more quickly if it runs a minute as opposed to an hour.
So I'm just looking to see if QEMU, the emulator, supports Itanium.
I don't
And
I know there
it
are VAX
says,
emulators and alpha emulators. I don't know if there are any Itanium emulators.
well, this is what I've found on Reddit, saying it's not possible to fully emulate it.
Yeah, but there's really no point, because the idea behind this Itanium was, well, after the VAX developed Alpha, which for a few years was the fastest chip in the world, and it was supposed to have a lifetime of 20 years or something. But then after about 7 years or so, they decided to stop development on it in favor of Itanium. And the idea was Itanium will be industry standard, whereas VAX, and well, at the time, VAX was one architecture of many, and Alpha as well. Apple had their own chips, IBM had their own chips, everybody had their own chips. And at some point, the Intel architecture sort of became standard. And back in the 90s, it was slower than the IBM chips or Alpha or so on. That's no longer the case. And the idea was that Itanium would be the new 64-bit industry standard, but it didn't turn out that way. So Itanium was, in that sense, a dead end. And the recent Itanium chips, they're quite fast. I mean, when I worked at the stock exchange, that's what we were running. But it's just become a niche market, because essentially only people running VMS run it. Although you could theoretically run anything on it. But that was the reason for Itanium. But Alpha was developed as, for a long time. And I don't think there are not really many features on Itanium which aren't on Alpha. Yeah. So if you're running on an emulator, you can just run an Alpha emulator. And on modern hardware, that will be faster than the original Alpha chip. Yeah. So there's really no point in emulating Itanium, because it doesn't. There would be a point if VMS on Itanium had some features which it doesn't have on Alpha, or some compiler or something, but that's not really the case.
So if I wanted to run VMS on my machine, I would use an Alpha emulator.
Yeah, or you could even use a VAX emulator, but an Alpha emulator would allow you to run a more modern version of VMS. Yeah.
Now, actually, I do have a connection with Alpha, which is that I didn't use Alpha machine, but I did decommission an Alpha machine, which was in 2003. The Open University was looking to remove some hazards relating to this tech installation, which was used for the production of course materials. And it'd been actually, it'd been developed in part by Chris Rowley of the LaTeX 3 project in the mid-90s, I think. And it was running on, well, when I joined the Open University, it was running on Alpha VMS. And that was in 2003. And they were concerned because it was obsolete hardware and obsolete software. And
what they had was obsolete software. They could have upgraded.
Well, the big problem, these people didn't quite understand how archival tech was, so they were concerned that it was an obsolete version of LaTeX. But I knew perfectly well that obsolete versions of LaTeX will work just as well on modern hardware.
Yeah, sure.
The big problem was the printer drivers, which were bespoke. They were bespoke to the Open University, and they seem to involve some shell scripts as well for dealing with PDF, EPS files. So that was actually the difficult thing. And there was this sort of language of specials that communicated at a fairly detailed level between the document and the printer driver. And I had to, well, the way I solved it was I sort of constructed a little interpreter inside tech using tech macros that would agglomerate the commands as they came through and produce DVIPS specials.
Mhm.
And that required me running lots and lots of documents to get lots and lots of listening on the wire to see what signals are going down. And I found that almost invariably the signals fitted various patterns.
Mhm.
And so those are the only things I had to write my emulator for. And there was one system, one situation where the pattern wasn't quite correct. And I had a look at the source code and found that there'd been a sort of error, if you like, in the copy and paste. And I could just swap two commands and that will change the
Mhm.
output slightly and simplify the. So I provided a translator that translated the commands for the custom printer driver to the commands for the DVIPS printer driver. And then all the stuff that ran on the alpha ran on the new system.
Yeah, sure. I mean, it's very portable.
And the other thing is we had to replace the version control system that the VMS provides, which I believe is quite good and quite liked. And I do remember a little bit about that.
Yeah,
And
I mean, the interesting thing is it's not some sort of add-on. It's there at a very basic level, and you know, so it gives you 32,767 versions per file, if you need that many, and it's just there. You don't have to think about it, and I've become so used to that, and otherwise you have some sort of add-on version control system where you have to do it by hand, and you know,
well,
I
it could
just
be
think
automatic even. It could be automatic even though it's not part of the operating system. But I know what you mean. But
yeah. I
you
mean,
have to make
another thing is the clustering capability, and the sort of so-called clustering solutions with other systems are usually add-on, sort of top-down, whereas in VMS it's there at a very basic level, this clustering functionality, and I think it's one of the main features of VMS is you can just have a cluster of machines and you don't even have to care which one you're on, and everything is shared. You know, so it's a great environment, and it provides availability. If the machine dies, you just continue on the others, and or you could upgrade one machine to a new operating system or test things out. You know, it would be the system disk would be on a machine in a cluster with other machines. So you could run stuff on one machine and on another and compare the output from different compilers or whatever. It's the clustering functionality is really, really great. And there's something called logical names, which is, I guess, in the broadest sense, like an environment variable, but you can define it, you can define a logical name and make it visible on all processes in the entire cluster. You could have 96 machines and they would all see it in real time. So it's really, really nice for that. And
So I'm reminded, it's a bit off topic, but Ericsson Swedish company make phone exchanges, and they require things like live updates. You can't stop the phone lines working because you need to update software. And a call, if you like, a call that's on one version of the software needs to keep running that software until it's terminated. The functional programming language Erlang came out of the problems of that domain and the Ericsson company. And I think that's an example of how hardware and software have evolved together in the same way as VAX VMS have evolved together to produce these sort of high availability stuff.
Yeah.
that financial institutions, for example, require. And the only other place that you get that sort of stuff would be from IBM. And I don't know what the IBM offerings were.
Yeah, I mean, these days, IBM would probably offer you Red Hat Linux with some add-ons.
Yeah.
In fact, I think IBM is the largest supporter of Linux these days, probably.
Well, it's the owner of Red Hat now, isn't it?
Pardon?
IBM is the owner of Red Hat.
Yeah, but not the owner of Linux. So there are other Linux distributions, but Red Hat is certainly one of probably the biggest one, right?
Yeah, when I was at the Open University, as a result of a project, I had a virtual machine web server. We were serving mathematical formulas. And every so often, the IT people that were managing all the virtual machines would move the virtual machine itself from one piece of hardware to another without interrupting anything.
Yeah, yeah.
And to me, that's a miracle, but it's much less of a miracle when you know that things were designed with that in mind. And on my rebuilt computer, I've done something I perhaps should have done before, which is used LVM, Logical Volume Manager, to manage the storage, even though it's just one solid state disk, essentially. And I discovered it has the capability of, so to speak, repartitioning on the fly, so that you can allocate 10 gigabytes to a virtual machine. And then while the virtual machine is still running, you can enlarge the amount of space, even though you're not doing it in a contiguous way. And not only that, but you can have a pool. So you can just add another drive if you're allowed to hot add a drive, and just enlarge, just give yourself, so to speak, it's like adding more RAM to the computer while it's running. And you can actually move stuff that is existing on one disk and move it to a separate disk without any interruption of service.
Yeah, what something VMS has had for a very long time is called host-based volume shadowing, which is a type of RAID where essentially you've got more than one copy of a disk, which is mirrored in real time. And at some point, they introduced the ability to have these disks a different physical size. But of course, the logical volume would be limited to the smallest disk. But you could add a disk of a larger size to this so-called shadow set, and it would automatically mirror the data. Then you could remove the small disk and add another larger disk and increase it. And it's completely transparent to anything which is running. I've actually done that several times. So you have some logical volume, but it can grow in size by adding more physical drives without the applications even noticing it. And within a single hard disk, there's also a special type of logical name called a concealed device, which looks like a physical disk to the software, but it's completely it has no fixed size. You know, you're limited by the physical size of the disk, but you don't have to allocate it. It just uses up what's available completely transparently. So I really can't. I mean, when I was at the stock exchange, I got the job there because I had some VMS knowledge, but with time, we had some Linux systems and so on. So, I've actually used both in a similar environment, but I really couldn't imagine voluntarily working with something other than VMS.
I understand your appreciation of it, and uh, may I suggest that you're skilled and you're very skilled and knowledgeable of VMS as a system administrator, and you don't particularly want to learn Linux as a system administrator. You already know VMS as a system administrator.
Yeah, I mean, I know some Linux because I used it at work, but it just doesn't appeal to me.
Yeah.
And the only real area where VMS has fallen behind is regard to web browsers. And that was my motivation to buy an iPad because I need a modern web browser for many things these days.
It's odd, isn't it? That you use VMS for the stock market, but to do banking, you need them.
Yeah. It's a bit strange. Yeah. And I don't know. I still think it's a majority of financial transactions are probably still running COBOL code. Yeah. And people think of it as this sort of obsolete dinosaur, but actually, people are writing new code in COBOL, and it's still very much alive.
Yeah, some of it is a matter of being risk averse, isn't it?
Yeah, and but it's also a matter of the right tool for the job. And I mean, COBOL was as the name says, it was developed with business applications in mind.
I'm vaguely reminded of the LaTeX people wanting to add tagging without breaking any backwards compatibility, and that's the sort of conservatism. That's the same sort of conservatism that leads to financial institutions continuing to use VMS. But actually, lots and lots of new documents are being created, and can't we create the new documents in a forwards compatible manner rather than wait until we've solved all the legacy documents? Somehow I think it's time for a new version of LaTeX, perhaps.
Well, there are new versions in the sense this LuaTeX and this PDF LaTeX and these things.
Well, they're variants. I think that's the point. The difficulties that provide a blockage to effective PDF tagging by the writings of Rowley and Mittelbach require a lot of changes because they weren't thought of from the beginning.
Yeah.
And it's, how can I put it? If the foundations aren't right, then the only way to fix the house is to demolish it and redo the foundations. Or another version of that, which is, oh God, I know what, it's an example of something like contingency planning, which is that you are building a car park, but you don't know how big it's going to need to be. So you build a 2-story car park, but you make sure that the foundations are strong enough to allow you to make it a 3 or 4-story car park.
Yeah.
I
mean, there's certainly a need for new things like UTF input, or the links, HTML links in a PDF file, or things like that. But it would be nice if all of these new things were in one application. I mean, it wouldn't be allowed to be called tech, but it could be backward compatible with tech. I mean, in the sense that you could put your old tech document into it and it would process it. But you've got at least 3 different extensions, if you like, PDF LaTeX, LuaTeX, and so on. And I think it would be nice to somehow combine those.
I've got a sort of funny view of typesetting, which is that tech is actually all about breaking things. Typesetting is about breaking things in an artful manner, because the page is not infinite in width and depth.
Mm.
And for that matter, neither our arms have got limited extent. There are the mechanics of hyphenation and ligatures and all sorts of things like that, and also the mechanics of math typesetting. But a large part of the essence of tech is actually going through the paragraph and just adding in, put a line break here, put a line break here, put a line break here. And then every so often you have to go through and say, not only put a line break here, but put a page break here.
Mm.
And then you have the multiple streams, the stream of footnotes, and they have to be combined. And so you've got the page makeup, but the page makeup is, in some sense, a separate program. And there's two proofs of that I can bring to you. The one is the hint software that Martin Ruckert has produced, that essentially separates the output routine from the stuff that goes into the output routine. So what happens when you write a tech document is that stuff goes into the output routine and stuff goes into the paragraph routine. With hint, that stuff is just put to one side and stored and shipped out as stuff to be processed later, a bit like the cow, sort of with its stomachs.
Mm-hmm.
And then the other side of hint, the stuff is all typeset, except we haven't actually decided where to put the breaks in. We haven't. So hint divides the process into two things. The one is typesetting things as if the page was infinite.
Mm-hmm.
And then the other is deciding where to put the breaks in and making up the pages. So that's the first thing. The other thing, if I can find it, so this is Page Tech, which was produced by a science journal publisher, and it's the 1990s, I think, 1992. So Life Science Communications developed this, and it's a publishing system based on tech that has its own back end for doing the page makeup.
Mm-hmm.
And apparently it's quite successful for them. So, and there's an article or two about it in Tugboat. So there's lots of possibilities.
David mentioned that some people use LaTeX and think about the presentation. I have to admit, I'm one of those. Not when writing normal documents, because that's up to the class, the document class or whatever. But I actually use LaTeX for making transparencies for talks or for posters or things like that, which are inherently visual. And LaTeX isn't ideal for that, but I found it's easier for me than learning some new program, and I can recycle anything I've written in LaTeX. I can just recycle it and use it there, which is nice. So now when I give a talk, I have, well, I've come up with my own format, which is essentially just the content, and it's processed by a script into some sort of LaTeX and then compiled. And I have a PDF which looks like, you know, I think many people probably couldn't distinguish it from a PowerPoint PDF, but it's all done in LaTeX.
I think there are a lot of things, people like you and I that sort of know LaTeX very well will pick up that tool because it's the tool we know how to use. And we've got a great advantage in using it to do things that somebody else what's the word? We use LaTeX for small things because we already know it. But somebody who's got a small thing to do won't learn LaTeX in order to do that small thing.
But on the other hand, there are people using LaTeX purely for content. If you look at Cambridge University Press, you see that there are many books which look almost exactly the same as far as the LaTeX goes, as far as the format goes. And that's because everyone is using some Cambridge University Press LaTeX macros to write their book. And I think in these cases, the author has essentially no input into the format and probably doesn't want to have any input into it. They just want to, say, here's the manuscript and you make a book out of it.
Yeah, tech has got traditionally the traditional sort of plain text LaTeX sort of stuff. For the context, I think is a sort of different area. But the
I'm not sure what context is actually used for. Is it?
Well, we'll have to ask Hans Hagen to come and tell us.
Mm-hmm.
I know the AMS. I used to be a member of it, and I'm a mathematician. And in that sort of area, it's really very, very solidly rooted, and whole production systems deal with it. And Paolo Dine Souza, who came the other week, uses it to typeset the proceedings of the ICM, and those sorts of things. And it's got a longevity because everything, so to speak, everybody knows how to use it, and to make changes would put many people's noses out of joint.
Mm-hmm.
But as years go by, young people replace old people, and old people and young people become old people. I was young once, and and we can't rely on inertia to keep everything going. And what's happening now is that young people don't watch television, or they might, but they watch it on their computer. But by and large, they watch things on the mobile phone. A lot of
they read PDFs on a mobile phone.
When I was growing up, the thing was to have a hi-fi with big speakers, and
exactly.
now the thing to do is to have something that fits into your pocket with a pair of headphones or earbuds. Well, I think we've sort of come to our end, and we've missed Nelson. He you might watch the video of this, find out.
Do you know when he'll be back?
He's back next week, I think. I think it's
okay.
It's just a holiday, that's all.